Okay, this is just, I'm just going to walk you through how to find the balanced equation for each of these steps in your reaction lab. So starting with number one, it says we have zinc that's going to react with a solution of copper 2 sulfate. So we'll need to write out a balanced equation, and from the beginning parts of the equation we should be able to predict, based upon the type of reaction we have, the products. So we know we have zinc, which is Zn. We're going to add it to copper 2 sulfate, so we know that copper is plus 2, sulfate is minus 2, so they'll go together, so that would be CuSO4. So our pattern that we start with is an element compound pattern, which suggests that this is going to be a single replacement. So zinc will replace copper and it will join with sulfate. Zinc is plus 2, so that would be SO4. They just go together, and then it will kick out copper here. And so once we've figured out our products, we can balance it. So we got one zinc, one copper, one sulfate, one sulfate. So that would be balanced. In reaction number 2, we have a solution of lead 2 nitrate that's going to be added to a solution of potassium iodine. So we'll write out the binary compound, so we know that lead's plus 2, nitrate's minus 1, potassium is plus 1, iodine is minus 1. So for lead 2 nitrate, that would be Pb, the nitrate, NO3, 2, because of the cross. We're going to add it to potassium iodine. And from our pattern that we start with here, we have a compound plus a compound. So that looks like it's going to be a double replacement reaction. So the potassium and the iodine will combine. So we'll have Pb with a plus 2 and I with a minus 1. So it has to be PbI2. And then we have the nitrate and the potassium. So that would be KNO3. This potassium is plus 1 and nitrate's minus 1. Now we got to look at balancing it. So I have one lead. I have 2 nitrate groups and only 1 here, so I'm going to need 2. I have now 2 potassium, so I need 2. And that gives me 2 iodines and 2. So that will be my balanced equation that I can use later when I have to solve a mass-to-mass problem. In reaction number 3 here, I've got zinc metal that's going to react with hydrogen chloride, which is also known as hydrochloric acid. So I'm going to need to figure out the binary compound of hydrogen chloride. So we know that's plus 1 and chlorine is minus 1. So the element zinc is not diatomic, so it's just Zn. These two would go together, HCl. Based upon what it's looking like here, we have an element plus a compound, so that looks like it's going to be a single replacement. So the zinc will kick out the hydrogen, so we'll have hydrogen, and hydrogen's diatomic, so it has to be H2, and it's going, zinc and chlorine are going to join. Zinc is plus 2, chlorine's minus 1, so it has to be ZnCl2. And now I can balance it. So I got 1 zinc, 1 hydrogen, 2. So I'll need 2. That gives me 2 chlorines, and I have 2 over here. So now that's balanced. So in this reaction number 4, I'm going to take hydrogen peroxide, which I've given you the binary compound. That's H2O2. And we're going to heat it. So I'm going to apply heat to it, and it's going to release water and oxygen gas. So in this one we have H2O2, and when we heat it, the heat is applied here, so it's going to break down into water, H2O, or hydrogen oxide, and oxygen. Oxygen's diatomic, so I need 2. So since we're breaking down, this looks like it's going to be a decomp reaction, decomposition. And of course I have to balance this equation. So I have 2 hydrogens, 2 hydrogens, 2 oxygens, 1 plus 2 is 3. So I have a problem. I have 2 and 3. So it looks like I'm going to need to make these a little different. So we make it even. So I have an odd even. So let's go with 2 waters. So that gives me 4 oxygens. So I'll need 2 here. That gives me 4 hydrogens. So that looks like it's balanced now. In this reaction number 5, we're going to take copper metal and we're going to combine it with sulfur using heat. So I've got copper, Cu, plus sulfur, S, and it's going to combine to form copper sulfide. Here, copper is going to be the copper 2 version, and sulfur, of course, is got a -2, so it'll just go together, Cus. And I'm going to check to balance it. So I got 1 copper, 1 copper, 1 sulfur, 1 sulfur. So this would be balanced. And since you're taking 2 things and making just 1 product, this would be a synthesis reaction. On reaction number 6, we're taking methane, which is natural gas. Methane has a chemical formula of CH4. That one I'll give to you because the hydrocarbons can be kind of weird. And we're going to burn it with oxygen. So we're going to add oxygen to it. Anytime you burn a hydrocarbon, you get only 2 products, carbon dioxide and water. The trick is to balance this, of course. So if it doesn't balance easily, I've given you a suggestion how to do it, but let's just check to see what we got. So we've got 1 carbon to 1 carbon, so that's okay. I have 4 hydrogens, but only 2, so I'm going to need 2 more. That'll give me 4. Now I have 2 oxygens here, and I've got 2 plus 2 more is 4, so I'll need 2 more over there to finish this out. So this is actually the special type of a synthesis, but it's also a combustion reaction. And in our last reaction here, we're going to take magnesium and we're going to burn it. So anytime you burn something, you're adding oxygen to it. And the 2 will combine, so we have to look at how it's going to combine. It's going to be magnesium oxide, and magnesium has a +2 oxidation over oxygen's -1, so it'll combine like that. These go together. And now we have to balance it, so I've got 1 magnesium to 1, 2 oxygens to 1, so I need 2, which means I need 2 magnesium over here. Since we're taking 2 things, making 1 product, this would be a synthesis reaction. So now what you can do is use all of these balanced equations for these 7 reactions to complete the calculation page of your lab, which is doing mass-to-mass problems. Good luck.